Welcome back to the show. Feels like we need some sort of a jingle or something. Welcome back, welcome back, welcome back to the Stats Show. Yeah. No. Welcome, 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 welcome. No. Everyone, oh, welcome back. The place where we pull numbers out of a hat. Yeah. No, that's just terrible. You wanna learn some stats? Come on over to my YouTube channel. Unless you have a hangover, 'cause you're not gonna remember anything I said. 'Cause you're gonna have a headache and require aspirin. I think that's a good one. Okay, welcome. Thank you for tuning in. Today we are talking about survey research. So without further... Forgot to introduce my guest. My bad. So you may have seen him, and let's see. I think they're up to 8 movies now, as well as other places. But our friend here has had a recent career change and has decided to become a quantitative psychologist. And I think you'll understand why. He has rapidly become an all-star in my field. So ladies and gentlemen, please welcome the one, the only, Yoda.
Pleasure to be on your show it is.
Total pleasure to have you, Mr. Y.
Call me doctor.
Oh, yep. My apologies, Dr. Yoda.
Much better.
Okay, so here are the goals and objectives for today. I'm not going to read them.
Yes, objectives and goals we have.
Are you going to do this the whole time?
What?
I don't know. I don't know. Guess we'll get on with it. Oh, that's the end of the slideshow. No, it ain't. Oh, start at the wrong place. When you start at the wrong place, you end at the wrong place. Okay, sampling methods. So, in an ideal world, there are 3 important steps to sampling. The first is you clearly define your population. And by the way, nobody does this, but that's what we should do. So, all single mothers of autistic children, for example, or all Rowan students who have depression, or all humans that currently live or will ever live. So once we clearly define our population, the next step would be to define a sampling frame. And a sampling frame is nothing more than basically an operational definition of your population. For example, patient records of autistic children at a doctor's office. So that might be your sampling frame. Or the student registrar at Rowan University. That might be your sampling frame for the kind of second bulleted point up there. Or undergraduate psychology students might be your sampling frame. I guess we should be a little more specific than that. That might also be student registrar records or whatever you call them. So let's look at, oh, look at that, I changed it. So I guess somewhere in there I changed it from the registrar to wellness clinic records, which works, I suppose. All right, so if we were to if we wanted to look at all single mothers with autistic children, and then we look at patient records of autistic children at a doctor's office, that's a little biased, because not all autistic children go to that particular doctor, and not all autistic children go to a doctor at all. So, kind of biased. And then we do a little better with the all Rowan students with depression, and then going to the wellness clinic records and identifying those who have been flagged with depression. That's a little better, but not everybody who's depressed goes to the clinic. And finally, all humans that currently live or will ever live. That might be your population, and you decide to study undergraduate psychology students. That is horrific in terms of bias and representativeness and stuff like that. Okay, by the way, I got a cold today, so I hope to edit out all the weird honky noises that my nose makes when I blow my nose, but if I don't, my deepest and sincerest apologies. I'll just blame it on Yoda. Number 3, randomly sample from the sampling frame. So a random sample means that everyone in the sample frame has an equal probability of being selected. Your book calls this probabilistic sampling, and we tend to use computers to do this, or we could use, a dice or anomalies in space. They actually do stuff like that. I don't remember how they do it, but you don't care. So I'm going to move on. Because it's very hard for humans to be random. What do we actually do? Well, we actually do convenience sampling. And convenience sampling, well, your book calls it non-probability sampling. So an example of this, the sampling frame might be undergraduate students in the SONA system, or it might be patients who come into the clinic. And so that might be our sampling frame, and we don't even randomly sample from that. We take all we can possibly get. So what are the consequences of this? Well, it's going to threaten external validity, meaning the results we find in our lab may not generalize to the population. Oh, and who's that name? 5-2013? Oh my, I heard of him. He's famous. He has his own TV show. Another day where I have 3 guests. Yeah, so my dissertations showed that statistical conclusions validity is also threatened if you use convenience sampling. And you guys saw that presentation a couple weeks ago. So estimates computed in the sample will be biased estimates of the population. Bazinga. Oh, wrong direction. So when would this be problematic? Or in other words, when would it be problematic that we have convenience samples? Well, first of all, when characteristics of the sample do not reflect characteristics of the population, and let's say these characteristics are correlated with your outcome variable. So some examples, let's say your outcome variable is academic achievement, which we know to be highly correlated with socioeconomic status. And let's say you're sampling undergraduate students. Well, undergraduate psychology student, or just undergraduate students in general, tend to be much higher in SES. So because that is correlated with, lost my train of thought. So your outcome variable is academic achievement, which is highly correlated with socioeconomic status, and your sampling procedure yields unrepresentative sample of socioeconomic status, so things are going to be off. Likewise, let's say your outcome is suicidal thoughts, which is highly correlated with depression, and your sample is generally happy. Well, that's going to screw things up. Let's say you are testing responsiveness to reward, which is correlated with self-efficacy. If you believe you have control over your own fate and thus can achieve these rewards, well, that's going to... so anyway, those are correlated. And if your sample tends to be optimistic, that's going to be different than what you would find in the population. Basic idea. So take-home message, if there are any characteristics in the sample that are systematically different from the population, and if those characteristics influence the outcome variable, we be in trouble, folks. By the way, we're going to talk about this a whole lot more in the multivariate class when we talk about missing data. But if you can't wait, and I totally get it, like statistics is fascinating, statistics is fun, statistics is bomb diggity, go ahead and watch my missing data video. Maybe I can figure out how they do those little boxes and say, link right there. Oh, look at that. I don't remember whether it's that side or that side. One of those sides. Go check it out. Okay, so what is the solution to this? We can do purposive sampling. So generally what this means is that if we sample in such a way that our sample's demographic match the population's demographic, such as we have X% of African Americans, X% of Caucasians, X% of Latinos, X% of Asians, etc., and X% of Yodaites. What do you call your ethnicity? Yoda?
Dagobites.
Oh, that makes perfect sense. Dagobites. Can I just call them Dagobites? Dagobites.
No. Offensive, we find that.
Oh. Didn't mean to cross the barrier on that one. So what, yeah, moving on. So, but what if demographics are not the only important variable? So, for example, if socioeconomic status is correlated with academic achievement, we can propose, oh, that's not an example. So, that's my rewind noise so I can fix the mistakes that I just made. Where am I? Yeah, what if demographics are not the only important variables? So if socioeconomic status is correlated with academic achievement, then we should probably purposely sample those lower in socioeconomic status. And sampling on demographics may not be the best way of trying to generalize our findings beyond the sample or that sort of thing. So the problem is you have to know what characteristics are going to matter, which is a difficult problem. So is this sounding familiar? So we have a distinction to make between random assignment and random sampling. So in random assignment, we talked about this, so we can quote-unquote control for characteristics we think might be confounding a relationship. So we talked about the vegan versus meat eaters example. So we controlled for exercise and still the effect was there. Then we controlled for compassion and still the effect was there, hypothetically speaking. And we could go on forever. And we had to consider every possible confound control for it. And even then, we could never be 100% sure that we had controlled for all these other explanations. So maybe it's just easier at that point to use random assignment. So that was our conclusion from last time or 2 times ago or whatever that was. With random sampling, we have the same problem. So we can attempt to purposively sample on the characteristics that are correlated with the dependent variables. So for example, we might purposively sample depressed people when we study suicidal thoughts. And low socioeconomic status for the same study, since socioeconomic status is correlated with depression. And stress. And we could go on forever, but still never be sure whether our sample is actually biased. So maybe it's just easier to randomly sample. Well, unfortunately, it's unavoidable. It turns out that doing a random sample is really hard. Like really hard. And so, as opposed to random assignment is pretty easy as long as it's ethical to manipulate the independent variable, or whatever you want to call it. But in random sampling, it's just like, unless you have a very small population that you're dealing with, it's really hard to overcome that issue. So, sampling from the population, I just made up a word. So sampling from the population is often very difficult and expensive and sometimes impossible. So what do we do instead? We do purposive sampling, but with replications. So we sample those high and low in socioeconomic status and study academic achievement. Then in a new study, we sample those high and low in motivation and assess their academic achievement. And sample, and sample, and sample. And hopefully we have converging evidence across...
I can't hear you!
Converging evidence across multiple studies! Yes. Are you sensing a theme here? Absolutely. So, in other words, replication across many conditions. Oh, Yoda, did you want to have a turn to say that? Converging evidence across...
Patronize me, you must not.
Oh. My apologies, Dr. Yoda. The internet as a possible solution. So there are some advantages of internet sampling and doing experiments on the internet. So the internet breaks outside many of the problems associated with convenience sampling. So you have a much larger reach and a much more heterogeneous sample, which makes it a whole lot easier to purposively sample. But there are some problems with it. One is that studies may not be portable to the internet. It may be that the manipulation you're doing, like therapy, can't really do therapy on the internet too easily. So your study may not be portable to the internet. It may threaten the integrity of research conditions. They're not standardized. You know, some dude might be taking a survey while he's laying in his bed, half watching Netflix, and another person might be very well dressed and dapper in his office listening to smooth jazz. You never know. So because there are a variety of conditions, that may threaten the internal validity, but it might increase external validity. Another problem is that the researcher is not president. Yeah, that's a big problem if the researcher is not the president. By golly, if you're not the president, you have no business doing research. So if the researcher is not present, I almost did it again. So let's say there's an adversive reaction to the experiment and no one is there to help out. Well, that could be problematic if a adversive reaction is plausible with internet research. So for example, if you are asking people their favorite color, that could be a trigger for some, that when they recall their favorite color, it might induce some distress among participants. And you had better have a psychologist there. Just saying. And then those who participate in research may be categorically different than those who do not. And I'm going to add one more. I read an article a couple weeks ago that talked about how MTurk, which is one way that a lot of people do purposive sampling, somebody found out that I guess certain participants had programmed bots to do their surveys for them. They were just collecting gabs of money from Amazon for total random filling out and that sort of thing. So there may be a quality control issue when you do research. So something to look out for. Survey designs. So we're going to talk about 3 different survey designs. One is a cross-sectional, where you measure one group. So cross-sectional, we measure one group of people at a time, allows you to see a snapshot of the behavior and the relationship. So examples, we might send out a survey among Rowan students asking their opinion of professor competencies. That ain't gonna look good, is it? And then, or we might ask an internet sample their opinion on gun control and measure their self-efficacy. So the limitations of a cross-sectional design is you can only make inferences across people, not across time. So the image of the behavior may differ from a longitudinal study. So that graphic at the top right gives you an idea. So we've got that's a cylinder, right? I don't know my shapes. Let's call it a cylinder, even if it's not a cylinder. A cylinder, and then you take a slice out of the cylinder and it's circular, and yet if you were to look at it across time, I guess that top to bottom dimension might represent time. It looks more, yeah. The circle looks different than the cylinder. That's all I'm saying. So much of human behavior is best considered across time. So here's an example for those of you who have watched my mixed models video. You will recognize this example. So suppose we have measures of mood and performance of 3 completely unknown and random people. Let's just, for fun, call them Donald, Hillary, and Obama. Does there seem to be a relationship between mood and performance? And what conclusions can you make about this? Well, what we could do is we could average people's mood within the repeated measures. So the star represents their mood / performance score. Oh, I'm sorry, we didn't average them. That's just their mood and performance score on a given day. So, but the dots here represent other times they could have been measured. So what do we find? we find that there is a positive relationship between mood and performance, that as your mood goes up, by the way, mood is higher values mean you're in a good mood. So as you increase in mood, your performance goes up. But maybe this is answering the wrong question. We want to know whether an individual's mood affects their own performance. And this is telling us that those who are high in mood tend to be high in performance. Well, that's a totally different question than the one we may be wanting to answer. Whereas a longitudinal analysis allows you to look at those changes within people. So now how are mood and performance related? Well, within a person, as someone's mood goes up, their performance goes down. So you might say they become overconfident or something like this. Something like that. Something like this, like that, like this, like that, like this, like that. So this is what a longitudinal analysis can do. It fits, or it at least has the flexibility to fit, a different pattern for each person. So that brings us to a longitudinal analysis. So we follow the same people across time. It allows us to see patterns across time within each person. And if you want to know how people change across time, a cross-sectional relationship will not give you that information. But then longitudinal analysis comes with its own set of problems. For example, we might have attrition where people drop out, which threatens the validity of results. And who wants to participate in such a long study anyway? Really, if people are asking you multiple times over the years different questions, it might drive you nuts. And then there's also reactivity. So the study might prime them to be different in the measure you're trying to measure them. So if you want to, for example, look at people's changes in political ideology over time, and you suspect that, I don't know, people might become more conservative over time, and you're asking them in the early stages their opinions on politics, the fact that you're asking those questions might prime them to behave to start to develop thoughts in a different way. And that would be a problem. That would threaten the validity of your results. So that was longitudinal. Now we get into the successive independent samples design. And what this is doing is we measure different people at different times. And this allows us to see how a population's behaviors and attitudes shift across time. So for example, that's what presidential polling does. So they release, I don't know, new presidential polls every couple days, it seems, whenever there's a new election. And those obviously aren't the same people. And so what we can do is we can track how opinions are shifting over time. So the weaknesses of this is it does not tell us how individuals change over time, because the same individuals aren't measured. And it doesn't tell us why things are changing, just tells us that they are changing. And then you have to kind of hope to identify why they're changing. And finally, the different samples may be qualitatively different. So if you're asking a question about, let's see, if you're asking a question of people in the 1980s, you might say, how righteous do you feel? And in the 1980s, that meant like, how awesome do you feel? Whereas if you ask that in the 1930s, they would think you're asking about their piousness. Whereas today you would be like, how righteous do I feel? That's just weird. And you would just, people just would respond differently across the generations. So you got to be careful about that. And then now that brings us to reliability and validity. So say we've got this questionnaire, and let's suppose it measures happiness. And we want to know whether our questionnaire actually measures happiness. What's another name for this type of validity?
Construct validity.
Dang, you got it, Dr. Y.
No. Yoda? Dr. Yoda, you must call me.
Oh, man. You are an exacting person, my dear Dr. Yoda. So how do we know whether our questionnaire actually measures happiness? Well, it must be reliable and valid. So reliability confers to the consistency of a measure. If we can't measure it consistently, there's no way you can measure it reliably. Well, that's basically saying the same thing. What I meant to say on that is if you can't measure it consistently, there's no way you can measure it validly. So if you were to speak in math-ese or in psychometric-ese, you would say reliability is an upper limit to validity. So if it ain't reliable, can't be valid. So how do we measure this? Well, we can do what's called test-retest reliability, where we can measure people twice and then correlate their responses and see whether their responses are similar both times. Now, technically, if I remember right, the reliability coefficient is actually the squared of the test-retest reliability, or the correlation between time 1 and time 2. Since all my thousands upon millions of YouTube watchers are consistently making these comments, correcting me and saying, hey, it's actually the square root of the correlation. So that's for you, my audience of 12. And then, yeah, so compute the correlation. So technical math trivia. Oh, look at that. I already said that. It was in the PowerPoint all along. I didn't have to get all defensive and stuff. So we can measure people's consistency to similar items. That's another way we can measure reliability. These are called measures of internal consistency. And you might have heard of what's typically called Cronbach's alpha, although Lee J. Cronbach didn't invent coefficient alpha. He just kind of made it popular, I guess. I think Cooter Richardson were the ones that originally created it. It used to be called KR20. Well, it's still called KR20 if you're looking at dichotomous item. Why did you don't care? Like, why am I saying this? You don't care. So I'm going to move on. There's also McDonald's omega, named after Roderick McDonald. And by the way, there are lots of limitations of those issues. We will talk about that much more in the measurement class. So think of it like measuring the correlation between the first 10 items and then the last 10. And then maybe you do another correlation between the even items and then the odd items. And then you think of another way to split them in half. And then you do that lots and lots and lots of times for every single possible combination of items you could think of. Well, that's basically what your internal consistency measure is it is the average of what you would get if you were to split your test in half in as many ways as is possible. So how do we increase reliability? Well, we can increase reliability of the test in 3 ways. One is that we can increase the size of the questionnaire. So do you remember the central limit theorem from undergraduate statistics? Probably not. Well, basically, there's some fancy statistical theorem that says the larger the sample size, the more confident we are that the mean of the sample is close to the population mean. Likewise, the more items we have, the more confident we are in their measure of happiness, or whatever construct it is we're trying to measure. Another way of increasing reliability is that we have a heterogeneous sample. Now, this is kind of different because normally when you're trying to compute like an effect size, you want a very homogeneous sample because heterogeneity kind of mucks things up. But in terms of reliability, you actually want a heterogeneous sample because heterogeneity means you can discriminate between people. And so the ability to discriminate between people improves reliability. So if all your people are practically identical, your test will have a hard time discriminating between people. So for example, if you give a first grade spelling test to adults, you will probably have very little variability. And so it's hard to tell who is a good speller from who is a bad speller. Oh, I said there are 3 ways and then I listed 2 ways. Is there a third way? There may be, but I don't remember off the top of my head. So minor tangent. Let me read some dude's comment on Malcolm Gladwell's, I think this is Outlier book, Common Myth. And I'll just read the quote. So the relationship between success and IQ had been studied often, especially in recent years. A high IQ does generally correspond to higher achievement, but there is a catch. Once a person's IQ is above 120, the direct relationship between success and IQ ceases to exist. Someone with an IQ of 125 isn't any less likely to win a Nobel Prize than someone with an IQ of 170. In other words, IQ has a threshold. If you're smart enough, you can have as much success as anyone else who is smart enough. That's Malcolm Gladwell's argument in Blink, and it turns out it is not true. And now that you have a little background in psychometrics, you can understand why that is. So here's the problem, is that IQ tests are designed to be reliable for average people. So it can discriminate among those who are average. So it can identify those who are smart from those who are average, and those who are not so smart from those who are average. But it has a terrible time differentiating between geniuses and super geniuses. So several decades ago, somebody had the brilliant idea, well, why don't we give 10-year-olds the SAT? So we got two kids that we think are really smart, and we want to know which of those is smarter. Well, if you give them at 10 years old the SAT, well, it turns out you can easily identify the super geniuses from the geniuses at this age. So now, having a really high score on SAT at 10 years old is extremely predictive of later outcomes. For example, Facebook's Mark Zuckerberg, Google's co-founder Sergey Brin, and here's a surprise, musician Stefani Germanotta, Lady Gaga. That's a lot easier to say. Those people were part of this study, and their scores early on predicted that they would be geniuses or super geniuses later on. And who'd have thought Lady Gaga was a genius? Like, really? Lady Gaga? Apparently she's brilliant. By the way, the source for that is that article if you want to learn more about that. So let me just say one final comment. The basic take-home message here is reliability depends on the characteristics of the sample. If you are trying to measure, it's kind of like if you're trying to measure the height of somebody with a measuring stick that is this big, it just ain't going to work. And likewise, if you're trying to measure a atom and you have a ruler, that ain't going to work very well. So your tool has got to be appropriate to the sample characteristics. That's all I'm saying. So that brings us to validity. So once we are reliably measuring the thing we're trying to measure, we need to know whether we're actually measuring the right thing. And that's where validity comes in. So are we measuring happiness? Or are we measuring reading comprehension? So far, we've talked about threats to construct validity, such as construct underrepresentation, construct irrelevance, and monomethod bias. Now we're going to talk about how to actually assess validity. So wouldn't it be nice if there was a gold standard of happiness? So if so, we could correlate our measure with the gold standard of happiness. And in situations like that, we call that criterion validity. So criterion validity means we have a gold standard and then we measure our people with our measure and see how well it correlates with the gold standard. Now, if you already have a gold standard, why would you develop another measure? Well, sometimes the gold standard might be highly intrusive or highly expensive to measure. So for example, you could do a skin biopsy to find out if somebody has cancer. Or not necessarily, you could just do a biopsy to find out if somebody has cancer. But at least in the early stages, it might be a good idea to do something far less intrusive and less expensive to identify whether they have cancer or not. So instead, we have other measures that seem... So anyway, we usually don't have a gold standard. So instead, we have other things that seem to measure the same thing. And if our measure correlates with these other measures, we might have convergent validity. So that's a different type of validity. So convergent validity means our measure correlates with things that should be correlated with a theoretical construct. So for example, our measure of happiness should be correlated with other measures of happiness or measures of well-being or those sorts of things. So, and likewise, our measure should be negatively correlated with BDI or Beck Depression Inventory. So these are all measures of convergent validity. So even with the Beck depression inventory, even though it's negatively correlated, we still call it convergent validity because it's correlated inversely with something that it shouldn't be correlated with. So likewise, our measure should not be correlated with things that theoretically should not be correlated with happiness. So for example, our measure should not correlate with conscientiousness, at least not highly. There's no reason to suspect that conscientious people are necessarily more happy. So we should measure the same person on happiness and intelligence, and they should not be highly correlated. That's the basic idea between on that. And we, by the way, we call that divergent validity. So convergent and discriminant groups validity. Now there's a distinction. So here we talked about convergent validity, which means two measures of the same thing should be correlated, and divergent meaning two measures that should not be correlated, shouldn't be correlated when we actually measure them. And then now we have discriminant and convergent groups validity. So suppose we have groups we know a priori are happy. So our measure should be able to identify this group. So for example, you might think, or you might say that Buddhist monks should have all high scores on happiness measure. And if that's the case, then we call this convergent groups validity. Now, as opposed to divergent groups, so our measure should also be able to identify groups that are not happy. So you might say that drug addicts should have very low scores on happiness. And if that's the case, then we have divergent groups validity. So now some miscellaneous stuff. Threats to self-reports. So if we have self-reports, there's going to be some threats to validity there, such as social desirability. So people might respond in a way that makes them look good. Also, behavior often differs from what they think they do. So you might ask somebody, how often do you pick your nose, for example? And they might say, I never pick my nose, ever. And then you actually record them, and it turns out they pick their nose a lot. So what people remember of their behavior might be different from what they actually do, especially if it's embarrassing. So how do we address them? Well, we have converging evidence, meaning we measure not just from self-reports, but we use reports from other people, we use biometric measures, those sorts of things. And then finally, correlation and causality. So we've heard this over and over again throughout our training as students and academicians. Academicians, is that a word? Academicians. Yeah. So does A cause B? Does B cause A? Or does C cause A and B? Well, just because you have a correlation between A and B, you don't know. So a spurious relationship occurs when two variables are correlated only because of a third variable. So for example, catching a cold and outside temperature. At least, you know, there's the myth, and that's why, there's a reason I'm air quoted it, that if you stay outside for too long, you're going to catch a cold. That's kind of a myth. The idea is that people, when it's cold outside, they tend to be inside a little bit longer or a little bit more, which means they're more susceptible to transmitting illnesses and that sort of thing. And there's some kinda about it. And then if you read that article, I believe it says something like, well, actually, if you are outside, it does something to your red blood cell count or something. I don't remember. Anyway, read the article. Correlational studies may reveal potential relationships that we could study in experimental study. And so correlations may be good at hypothesis generation. And then we could subsequently follow those up with experimental studies, and then we'd have converging evidence, which is super cool. So with that, there are the goals and the objectives. Be sure to read them, make sure you are good there. And with that, thank you all for joining me today, and also give a special thanks to Dr. Yoda for joining us on the show. Do you have any last words of wisdom?
Try not. Do or do not. There is no try.
Wise words from a wise man.